All right, let's go over the 5.5 practice. Question 2. An expression is written in logarithmic form. Which of the following is the equivalent exponential form? So it's always going to be your base down there. We start with that. We raise it to the power of the other side of the equation, so to the g power. And then we set it equal to the value inside the log, so n. A to the g power equals n. Question 3. Which of the following is the equivalent logarithmic form? So in this one, just kind of work the other way. You say log. Your base is still going to be the base of the exponent, so little 9 down there. But in the log itself is going to be this number here, what it equals to. So the 1/3 is going to go in the parentheses. But then it gets set equal to the exponent, which is -1/2. So your exponent in the exponential form is on its own in the log form because the logs solve for the exponents. So it's 9 to the -1/2 power equals 1/3. Question 4. Little matching exercise. So I like to go, I'll actually start with the logarithmic form. It's easier for me to go from that way to the exponential form. So let's start with A. Z to the x power equals y. Z to the x equals y. I'm just going to write them out and then we can match them. Y to the x equals z. See how I'm going out and back? So y to the x equals z. X to the y equals z. Y to the z equals x. And x to the z equals y. So you can match those up, but those are the right answers for each of those. Question 5. A logarithmic parent function is shown below. F of x equals log of base 4 of x. If the function of f of x is translated 3 units to the right and 5 units up, which is the following function? So what I say is it's just basically be log. I just say y equals or f of x equals log base 4. Always start with the base there. So now you're going to have some parentheses. So 3 to the right, it's always going to be minus in the parentheses. So it's going to be x minus 3. And 5 up is going to be plus 5. Now this is where using your Desmos might come in handy. So you could say f of I'll just say y equals log shift minus 4 of x. So you can see that original graph. Then do the same thing. Just to verify that you did the right movements. So I can see it's gone right. The blue function went right and up. So it looks like it went right 3 and up 3. And we can kind of maybe use a couple, might not be able to use any specific values, but hopefully you can kind of see that right 3 and up. There's a number there we can use. It went right 3 from 1 to get to 4, and then up 5 from 0 to get to 5. So there you go. Question 6. We want this to go 6 units to the left from log base 2 of x. So say y equals log base 2. Left is going to be in the parentheses, and that's going to be plus, so x plus 6. And there's no up or down, so we can just kind of verify that that is correct. Put a 2 there. 2 there, and 6 left would be plus 6. So let's just make sure we got that. And it looks like I took it left, so we're good on that. Question 7, what's the vertical asymptote? So the vertical asymptote's basically just going to be the opposite number in there. So it's going to be x equals -4. Remember, an asymptote is a number where there is a line that the graph approaches but doesn't touch. So if you graph the log function, log base 5, x plus 4 minus 2. And if you put in the equation x equals -4, you'll see a vertical line. And what you want to look for is basically that line to hug the part of the log that's going straight. Looks like it's almost going straight down. It's not straight down. There's a ever so slight bend to it, but it is approaching that line. X equals -4. You don't want to do 4 because 4 is going to be going through it. We don't want that. We want it to be at -4 because it was shifted left 4. All right, number 8. So what do you do when there's nothing in the parentheses? That's 0. So you'd say x equals 0. And we can back that up here. And you can see here, it basically hugs the y-axis. So 0 is going to be your answer. X equals 0. Number 9, inverse functions. Logs are inverses of exponentials. So anytime you have a basic exponential function, a parent function, the log function, the inverse would be, always use the f -1 notation. But you just say log, whatever the base is. So log base 2. And if it's just x, it's just going to be x. And remember that they are reflections over the line y equals x. So if you did 2 to the x power and log base 2 of x, and you graph the line y equals x, those should be mirror images over each other, which in this case they are. So that's what we want. So there's number 9. When you start shifting it, the inverse function f of x is 4 to the x minus 3 plus 5. So number 10, the way that looks is you'll say the inverse function. You're gonna say log base 4, always whatever the base is. But in the parentheses, you won't do x minus 3, you'll do x, or x plus 3, you do x minus 5. So we're going to take the number on the outside, change the sign, and bring it in. And then the number up here will go outside, change the sign, so plus 3. So let's back that up. We can do, clear all that out. So I'm going to leave the y equals x there. So we do 4 raised to the parentheses x minus 3. You got to have parentheses in the exponent, plus 5. So there is the exponential function. And then the log function, log base 4, x minus 5, plus 3. And what you want to look for is that reflection of the line y equals x. So it looks like those are mirror images of each other. So we're good. And question 11, last one. The inverse function of 5 to the x plus 1. So 5 to the x plus 1. So inverse log base 5. And you have a plus 1 on the outside, so you're actually going to have a minus 1 in the parentheses. But you don't have anything up here. So it doesn't look like any other movement's going to happen. So let's verify all of that. 5 raised to the x plus 1. And a log base 5, parentheses x minus 1. And y equals x. And we're good. So that's the 5.5.